I'm going to be doing page 588, number 72. Heat to the glass. How well materials conduct heat matters when designing houses. It goes on to read all about conductivity. And then it says, here are measurements of the heat conductivity of 11 randomly selected pieces of particular type of glass. Is there convincing evidence that the conductivity of this type of glass is greater than 1? Carry out a test to help you answer this question. Okay, now we're going to use TOMS now, and we know we're using TOMS because we're dealing with quantitative data. When we're dealing with categorical variables, we're dealing with ZOMS. ZOMS, we use the chart. TOMS, we use the calculator. Our first part of state plan due. I don't have my special pen today. What's it called? I forgot what it's called. But anyway, so it's going to be a little messier. I'm sorry. In the state, we need our null hypothesis, our alternative hypothesis, and name the parameter. We're dealing with averages, mu. The mu is going to be the average heat conductivity. Of homes in, and then I'm going to skip the label for now, just because I'm writing out of room. We have mu and we have mu. We want to find, is there evidence that it's greater than 1? We always set that equal to whatever it is, then those will always match. There's my state part. My next part is my plan. Okay, first I'm going to do the conditions. Oh man, this is really messy. We are running. Is it random? It's stated random. Is it independent? Okay, so 10 times 11, not homes, but selected pieces of glass. So that's our sample. That needs to be less than, capital N, all glass. Is that reasonable? Yes, check, move on. N is your normal condition. We're dealing with N is greater than 30. Is that true in this case? 11 is not greater than or equal to 30, So we have to do a check. I'll do the check on the next page. When I plot it out on a dot plot, if I start at 1.08 and go by twos, 1.10, 1.12, 14, 16, 1.18. I have 3 dots here. I have 2 dots here. 2 dots here, 2 dots here, and 2 dots here. That's a really messy dot plot. I apologize, but we can say this is symmetric enough with no apparent outliers. We're ready to proceed, so we need to say our method. Our method is a 1 sample, T interval for mu. State plan due. Okay, I'm going to draw my curve. My mu goes right here. My mu is equal to 1. I need to do some side work, or I can run my calculator. I need my x bar. I need my standard deviation. I need my degrees of freedom. I also need my t value and all of that, but I'm going to put it in my calculator right now. There were some people who are struggling with the calculator still. Let me talk you through it. I don't have a calculator I can show you on here, but I can talk through it. Get out your graphing calculator now, and in your graphing calculator, hit Stat, enter on Edit, and in L1, enter all your data. Pause now to do that. Once you have it all in your calculator, hit Stat, arrow over to Test, go to T-Test, hit Enter. We have data now. We are not given statistics. We have data. I'm going to keep my cursor for the input on data. The mu naught is whatever you set your null hypothesis to, and that's 1. The list is whatever list you have your data in. I have mine in list 1. The frequency stays the same. And then your next is your alternative. How did you set your alternative? And our alternative is greater than mu naught. So I'm going to arrow over all the way to the right where it says greater than mu naught. And then I'm going to calculate. When you calculate, it gives you that x bar. The x bar I'm going to plot right here. X bar is 1.123. Already we have evidence that it's greater than 1. We just want to know how significant is that. Our standard deviation, we take the SX they give us, 0.0429. We divide it by the square root of 11. Our degrees of freedom are 11 minus 1, which is equal to 10. And now we have to find a t-score. T is equal to our observation, 1.123, minus my mean, divided by my standard deviation, which is up here. I'm just out of room. Oops. Sorry, that arrow was bad. I don't know if I can undo it. Shoot. And I can't move it. Well, anyway, there's your standard deviation. I'm just running out of room. I'm going to go to the next page. So my t value, then once you calculate that, is 9.0540. That gives me a p-value. Again, this is all in the calculator. And you see that it's e to the negative 6. That's almost 0. So that's 0 point, it's scientific notation, remember. 1, 2, 3, 4, 5 zeros, 4. That's an incredibly small p-value. Now set up your conclusion. Your p-value is less than your alpha. When your p-value is less than your alpha, the decision then is to reject H naught. You have evidence for HA. Okay? Other way around, when the p-value is greater than alpha, you fail to reject H naught. You do not have evidence for HA. Now let's conclude. Because our p-value is approximately 0, I'm going to say because there's just so many zeros. For a test statistic, that's your t-score in this case, or your z-score if you were dealing with proportions. So for a test statistic of approximately 9.05, we reject H naught at alpha equals 0.05. We have evidence to believe the conductivity, excuse me, I forgot a keyword, the average or the true average conductivity of glass is greater than 1. And that is number 72.